Bismillah ar-Rahman ar-Rahim. Merry Eid Fitr Mubarak to all of you. Today, at my video, I will try to explain how we can solve this unsolved question related with the focal length. I explained before at the previous lecture, our purpose was to determine, or let me say, to know how we can determine the focal length of a specific convex lens because we didn't take concave lens yet. The question says determine the focal length to dental lens according to the column below by using window method and plots its curve. It's necessary. Why? You can do comparing between these two results, the results about window method and plots results. Okay, we have two columns, distance, and the deflection between lens and the screen. All of these results, then results the same is centimeters. Let me increase the screen a little bit. It's better now. After that, when we have the distance between lens and the screen, that's mean between lens and the screen, that's mean V. Now I have all the distance between the object or picture to the screen, that's mean all the distance. Its name is D. And the distance between lens and screen is V. It's important. You must know the difference between U and V. Here I'm talking about V. By that, when I have the distance and V, I can calculate U by saying D minus V will equal U. Okay? Because why? I'm repeating that because V plus U, it's equal the all distance. Okay? That's mean here by a simple math equation, I calculated U. It's just 29 minus 50 equal 21 and going like that. By that, let's calculate all of the U multiple V and U plus V. Why? Because we will use all of these results in the final focal length equation. I have all of these results. I did a rounding number. Why? Because that will be very helpful to me when I will started to plot the necessary curve. You can manage the last result. You can do comparing with a usually method, the window method result, and to know these results is near from other or not. By that, I can decide these results are acceptable or not. Now let's start from 609 will be 610 and going like that. It's necessary. I'm repeating that when you will upload your curve. Okay? U plus V, that's mean D, 50, 60, 70, 80. F, the focal length distance. From this equation, the inverse of focal length equal inverse U plus inverse V. By using simple math equation, we can simplify this equation more and more to avoid inverse all of these results, to avoid putting more 3 columns. Okay, that will be F focal length equal U multiple V divided on U plus V. By that, I have all of 4 near results. Okay, all of these results have the same unit, centimeters. Now, by taking the average to all of these 4 results by put plus between these two four results and divided on the same number is 4, I have 12.77 centimeters. That's mean the focal length to this convex lens is 12.77 centimeters. That's mean from the center of this convex lens, I can use ruler to decide the 12.77 centimeters after, from the center, after 12.77 centimeters, this the focal length, the focal distance, sorry, from the left and the right, because we explained that before. Any lens has two faces, the same from right, the same from the left. By that, the same focal length from these two faces. That means after this number, I can put a dot and saying the focal point is here. The lens, how I can say, the reflected light rays are reflected, the reflected light rays are converging at this point. Okay, this is the converging point. Now, the first method is done. Let's go to second, is by using the plot curve. By plotting curve, we can determine the focal length distance. And we will compare with this number to say it's near or it's acceptable or not. That will depend on the second results, if we'll be near from it or not. U multiple V will be at y-axis. U plus V will be at x-axis, like that. Let me just decrease the screen a little bit to be better. Yes. Here at x-axis, each 1 centime equal 10 centimes of U plus V. By that, 1 centime, 10, 20, 30, until 50 to 80 centimes. And U multiple V at y-axis will be each 1 centime equal 100 centimes of U multiple V, to be like that. 1 centime, 100, 200, 300, 600, and each 1 millimeter will equal 10 centimes of U multiple V. And after that, let's calculate the slope. Why? Because from this equation, we take the look, F equal U multiple V divided on U plus V. Let's take a look here. Slope will equal what? Slope equal delta Y, that's mean U, delta U multiple V, divided on U plus V. Okay, that means slope, it's actually equal the focal length. By that, by calculating slope, we can know the result of focal length by using this plotting method. Okay, I selected these two numbers. You can select it another, but except this irregular point, because if you select it, you will take far away results, a far result from our fact results. Okay, that will be a bigger problem. Let's come back to our solution. Slope equal these two results divided on 70 minus 60 to be equal 15 centimeters. Actually, the result is not near from each other. By that, I can say the result is not acceptable, but I will say that at the conclusion section, the relation between U plus V centimeters at x-axis and U multiple V centimeters at y-axis is linear relation. When one of them increase, the other will increase too, and vice versa. That's it. Our solution is done. Thank you about your watching, your listening. Have a good day and see you in the next video.